How would you add up the numbers 1 through 100? Would you just add them together one at a time until you get to the end, or would you search for a shortcut? Well, a formula exists that can get us the answer. It is n times n plus 1 all divided by 2, where n is the largest number we're adding up to. Let's test it. Consider the following three values of n. Their sum from 1 to n written out looks like this. For n equals 3, 1 plus 2 plus 3 is equal to 6. To save time, the sum of the other two examples is here. Instead of summing these by hand, we can actually use the formula I mentioned at the beginning. Here is the formula again. We sub our n value in for each one, which is the highest number in our sums. And the result from subbing the n values in is exactly the same thing as if we were to sum up the values by hand in the middle. So where does this formula come from? Well, let's get to it together. First, let's let s sub n be equal to the sum of 1 plus 2 plus 3 plus all the numbers all the way up through n. S sub n is the sum of all natural numbers from 1 through n. Our goal is to find a formula for s sub n. Now, s sub n gets lonely, so I'll bring out a twin s sub n below it, and it is also equal to the same sum. All I have are two sums of the numbers 1 through n. We could reorder the second s sub n from largest to smallest, and it would look like this. Now, let's match each number found in the same position of the two sums. So, 1 from the top will be matched with n from the bottom, 2 will be matched with n minus 1, 3 will be matched with n minus 2. Imagine doing that for all numbers in between. N minus 2 from the top will be matched with 3 from the bottom, n minus 1 will be matched with 2, and n will be matched with 1. How many matched pairs do we have? Well, since we are summing 1 through n, there are exactly n numbers in each sum. So there are n positions in each sum, which means we have n pairs of matched numbers. Just remember that there are n pairs of numbers here. We'll be using that later. Now, let's just add vertically on both sides of this equal sign. On the left-hand side of the equal sign, we have s sub n plus s sub n, which is equal to 2 times s sub n. On the right-hand side of the equal sign, when we add vertically, let's just add each of our matched pairs together. 1 plus n is equal to n plus 1. 2 plus n minus 1 is equal to n plus 1. 3 plus n minus 2 is equal to n plus 1. Jumping to the last three pairs, n minus 2 plus 3 is equal to n plus 1. N minus 1 plus 2 is equal to n plus 1. And n plus 1 is equal to n plus 1. What do you notice? Each one of our pairs that we match together is equal to n plus 1. How many pairs did we say we had? Well, we have n pairs since there are n numbers from 1 to n. So we have n plus 1 added together n times. This means that we can rewrite the right-hand side as n times n plus 1, since we had n plus 1 added together n times. So we now have 2 times s sub n is equal to n times n plus 1. Remember, we want to find a formula for s sub n. This means we want to get s sub n all by itself on the left-hand side. To do that, we could divide by 2 on both sides. We end up getting s sub n is equal to n times n plus 1 all divided by 2. This was our goal. We found a formula for s sub n, which lets us quickly find the sum of 1 to n for any natural number n. So to revisit the initial question of this video, to add up 1 through 100, I can use this formula. S sub 100, which is the sum of 1 through 100, is going to be equal to 100 times 101 all divided by 2. This will give us 5,050. I'm Joe, and thanks for spending some time with me.